Good morning. Happy Sunday, everyone. We're back for Tutorial Sunday with Introduction to Rust. Good morning, Bear Doodah. And also, that was an excellent drop that last time. And this one is shaping up to be another good one. There we go. All right, so let's switch over to the main screen. Excellent, we got everything here. I didn't stream earlier in the day. I ended up taking a slow morning through the house, watching Halsey's stream. He's getting some nice islands up on his, so that's been a lot of fun to watch. Godot Godot. I don't know. I still don't know how to pronounce it properly with Rust. But today, Go dot. Okay, Go dot. Yeah, I've heard it pronounced in a like those two different ways across different mediums. So, I wonder, like, how does the Go dot team themselves pronounce it? All right, so. The author says dot, so make of that what you want. Well, in that case, the appropriate thing would be Go dot. All right. As long as they don't pull a GIF thing where the maker does both of them as official methods, and then that everything is terrible after that. All right. So what are we doing today? We have, last time we finished up our to-do project that basically is, these are what's, the user stories for actually getting that project done. And so what I would like today is to create a list of the tutorial items that we want. I don't care what the GIF guy says, GIF is pronounced GIF and not GIF, and definitely not GIF. I like to say it like that because then it just sounds crazy. It was fairly funny. What ended up happening with that? If you haven't heard like the entire debacle with the creator of GIF or GIF, or depending upon which way you want to pronounce it, he came out in like a conference or something and said, "I pronounce it like this. This is the appropriate way to pronounce it." And then like several years later, he came out at a different conference and says, "I've changed my mind. Like now I say this one," but he didn't. So now both of them are like, yeah, that was not the best. So Go dot is what I'll try to remember to state. Can't promise. All right, so short for graphics starts with a G, not a J. So yeah, maybe. Graphics. We could call it that, graphics. All right, enough of this. So we have like potential how to use that we want to put into here. I think for right now, we want, what is this? This is gonna be the episodes, like the lessons. So like the lessons like for what you need to get here. I'll probably like end up putting this into like a separate repository at some point in time. Maybe one that I call like Introduction to Rust course, or I don't know, something else like that. But until then, we can create our list right here because we're starting with the end in mind. So the idea is that at the end of this course or series, we're able to make this on our own as sort of like as it's the assessment, the test, as it were. I'm really big on assessment-driven education. I was a teacher for 3 years, and I really do believe that micro assessments and then big assessments are like really, a big part about how we learn and how we teach. So this is what I would call a scrimmage assessment, meaning it's basically a real life assessment. You start from nothing and build this thing up, just like you would if you were handed a task like a new project from a project manager and you need to do it, this is what you'd have to do. Whereas we can, each of our lessons, I want to do micro assessments, which are really going to be more of drill assessments. That's sort of like if you think of soccer or football, depending upon which country you're in, the foot soccer ball, then that you'll see people drilling by, okay, let's dribble down the field. Let's practice this one shot. And then you just do that like 5, 10, 20 times in a row that you're successfully doing it before you can move on to the next one. That's drilling. And I think that's also equally important, especially in like software development too. It's maybe surprising the amount of drills that we can actually do. So that's what I want this course to really like focus on that style of things. And I really haven't seen very many courses on YouTube do that. So that's going to be also my niche for it. So, all right, lessons. This will probably end up being a table eventually. We can start with maybe just a list of these and then like break that out. And then we're going to take one of them and sort of figure out what our cadence and like what they're going to look like. And then I'm going to want them to all sort of kind of have the same layout as each other. So that way it's very familiar when you're jumping from one to the next. So with lessons, obviously there's going to be the introduction to the course. We're also going to have, do you want star or do you want dash? Let's see, introduction to the course. We're going to have installing Rust. We probably also want like why Rust? Why learn Rust? This probably is something we want to like go up on top. So inside of here, there's probably going to be multiple of these, right? We're going to have Windows, Mac, and Linux. I'm really envisioning that each of these lessons are going to be really, really short. And like, I might even call these episodes or I don't know. I don't know if I wanted to use the word lessons for it, but we can go back and change that up. Okay, so installing Rust, then obviously we have the hello world. So that would be setting things up. I don't necessarily know if I need to go over like the cargo.toml or anything else like that. That'll just be like initiating, creating, and running your first program. Once we set, oh, you know what? Setting up VS Code. I think I'm just gonna do VS Code for this one. VS Code is available on all 3 operating systems. And if anybody I'm sure there's plenty of setup videos that people can go to like see other ones. I don't necessarily have like Vim or anything else set up for like doing a tutorial on that with VS Code with Rust. So we'll probably need this. You know, I wonder if this would actually make sense to go after the hello world, because in hello world, there's literally nothing we need to do with an editor. Like there's no actual coding for that. All right. So then once we have that, let's actually start looking through this code and figuring out what do we actually need to do. So like cargo new is very similar to like the hello world. So we've already got that. We're not bringing in any dependencies as part of this. So I think the cargo toml we don't have to touch. With our main, we're gonna have to get the arguments out. So to get the arguments, well, that's creating variables. So this might be something like the basics. It's like the basics of Rust. And inside of here, that's going to be like variables. Now, maybe in the basics, we're going to have vectors and like strings, probably. That makes sense to like have like the data structures available to us that we really need for this. So vectors. Now args isn't going to be as part of basics of Rust. This is going to be like essentially the standard library. Arguments from the command line. Now this entire thing is fun. This is all part of iterators. So iterators specifically. Now I don't actually know if I need to like show off skip. But collect is important. It's like collecting into vectors. So skip, we can put a question mark there. But collect is going to be really important. Something else that's going to be really important as part of the basics of Rust here is going to be documentation. So using the documentation. Now here we have like a vector of string, and here is a vector of to do. So we're gonna want like the type system. And I guess like just know that we have like provided types and then new types. Blotzosaur, hello, good morning. So this is going to be, what is it? The primitives. Oh, what are the non-primitives that the what are they called? Or I guess like then there's custom type, custom types. I forget what the non-primitive types are called. Like, does the library actually say like anything about, okay, we have the primitive types and then just other types? Because like in JavaScript, we'll call them like, okay, we have the primitive types. That would be like a string, a number, let's see, like null. But then we have the reference types as like the other type of types, which is object, Boolean. Yes, Boolean, of course. Which of course here all of these are just under primitive types. And then I guess we just have provided types, which almost to me would be like they're actually just data structures that then hold types. So like a vector isn't a type, a vector holds types, holds like things of a type. So perhaps like under vectors here, we should really do data structures. And so we're going to want to talk about vectors. We want to talk about arrays. Even if we're not using arrays in here, because if you're coming from another language like JavaScript, where all you have are arrays, you're going to search for that in their documentation. You're going to find arrays and then be very disappointed that you can't use them in very similar ways to JavaScript when there's vectors that do all of that stuff for you. Okay, so let's see. Let me actually reverse this. README, you go over there. There. That way I can't accidentally cover any part of the code. And I can even do this. Yeah, that far over. Coming from JavaScript, people might be confused about not being able to mutate a constant. Yes, that's a really good. So like part of variables is also going to be like the difference between like immutable, immutable versus mutable. And then also as part of variables, we're also going to have reference. And then functions. So that's like, then we get our collect. Then we have our to-do items. Okay, so basic Rust to-do. All right, so then this is like the module system. So the module system. Now the big thing here that we really care about is running methods, like running functions in another file. For example, this run here. But beyond that, we also need these use statements. So then this. So this is going to be the first time we would run into, hey, a string versus a string. What is this? This is, well, it's a string. Oh, okay. Can I add to it? Oh, no, you need a string in order to mutate it and like, change its size. And then everybody just like throws up their hand and goes back to JavaScript. So we have like strings versus strings. And in this case, a string slice or a stir is nice, but we're gonna have because like technically, so correct me if I'm wrong, but aren't strings, wouldn't they technically be under data structures? It's like a string, but then we also have primitives like stir. We're using a number here that's a usize. So okay, so passing, so this takes ownership of this thing. So basics of Rust. So I don't know if I want to put that under functions. It might really go very well with functions of like ownership, even though it's like a big block thing. But when you like, it's very easy to see if I have another function and I pass something into it, that function now owns it. Even though I could do very similar things with just blocks in the middle of a series of statements. Okay, so then we have this unwrap thing. So what are you return? You're returning a result. Okay, so then we're gonna have error handling. So that means the result, results, unwraps, unwrapping. There's no concept of null in Rust, right? Yeah, so it's it's a little bit tricky if you're looking at Rust for the first time. You are correct. There is no null in Rust, but there is a none, which might confuse some people. So for example, if I were to come in here, I could say let this is nothing equals none, like that. And one would be forgiven for feeling that this is just a different word for null. But if you notice here is this shows that it's option unknown. That's because none has to be paired with something called a sum. So like it's either nothing or it's something. And then the compiler will then force you to sort of handle one or the other cases. So yes, there's no null, but there is an alternative to null that allows you to sort of like kind of get the same benefit of null, but without any of the negatives of null. But yeah, that's a really good point. We're gonna want under the primitives, essentially, none is not a primitive. None is an arm of an enum. So data structures, we have enumerators, enums. And specifically with enums, I guess like we have error handling. We're also gonna want to put in like something about null. What about null? None, some. And this is gonna have to be an if let. Nah, let's not put that there. And the compiler makes you handle all of these cases, you think. Yes, the compiler makes you handle all the cases or specifically states, I don't want to handle the cases. Go ahead and crash if it's not right. So for example, if I have like a function, maybe, and this returns, so I can't return like none right away. Actually, I probably could. I probably could just return none, but that would be very simple. Let's say I return an option, and the option is going to be like a bool. So maybe let's just make this an I32. It returns a number. So I could just straight up return none from this. And then so let's maybe something equals maybe. And we'll see that I've now got a none in here. But the compiler doesn't know that. The compiler doesn't know that this is a none at all. All it knows is that this is an option. It could be a none, but it could also be a number. So it yells at me until I handle it. An unused, unused variable. Let me like first match on maybe something. And then if I go none, I want to print line, it was nothing. But if I just do that and end this, hit return, it yells at me saying, hey, you haven't handled everything. You must handle the case where this wasn't a none, but it's something. And like as a developer, I know that this is never going to be anything other than none because I've written the code this way. but the compiler protects us in that specific case by saying, no, 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 what if this is a number? Now, handle that. So, okay, it was the number So something like that. So that's where that all is. And so yes, Blottosaur, you're correct. This is how the compiler forces us to handle them. Of course, we can ignore the compiler to a degree, to our, potentially to our not greatest. There is a null in Rust and a mutable null, standard pointer null mute. Wait, really? Museum with the knowledge. Okay, so hold on. So can I let totally null equals standard pointer null creates a null raw pointer. Huh, okay. So I do that, and oh, safety. Do I have to put this in unsafe? I have to put this in unsafe, don't I? Yeah. Okay, so immediately notice that I tried to set this to null, and it's not letting me do this at all. So I have to now throw this in an unsafe block in order to use this. Is that even? That error is because you didn't say what the T was. What T? I don't even have a T. Let's see. A null pointer is never valid, even for access size of 0. Wait, so how do I use this? Use standard pointer. Let T is a const I32. Oh, okay, so you set it to null to begin with. So like I have to set this to be like an I32. And that has to be a const? Like a dereferenced const I32? Oh, it does. Okay, so I have to dereference a constant I32 to get a place in memory of where it's going to be. And then that's where it's a const non-mutable pointer. Okay, so star point or asterisk const means it's a raw read-only pointer. Interesting. I'm so used to seeing asterisk as being a dereference, but I guess that's still a pointer to like the place in memory. So like reference to T is a read-only borrow of a T. Okay. And I'm going to need this to be mutable if I want it to be not here later. This is saying unnecessary unsafe block. So okay, I don't need unsafe here. I could do this. Rest goes the extra safe and differentiates between raw pointers. Oh, okay. So there are different types of raw pointers. Interesting. And so if I want to like set totally null, if I want this to be mutable, and set like totally no to be an I32 later, can I actually do that? Like 32. Expected a pointer found use size. The binding is mutable, but the value can't be mutated. Okay, So expected a raw pointer const I32. All right. I think I would need to like play around with this a lot more before I actually truly understood like what's happening behind the scenes. But that's really cool to know that it can be done. All right, so where were we with this? We did all of that stuff. Yep, the safety is still there, even on the unsafe side of things, which is something I really like. I've never had to like go into the unsafe side of Rust with what I've programmed so far. I have noticed that like Mr. Halsey, for example, has to delve into that side because he's working with C++ libraries a lot, and that forces him to go into the unsafe size. Which one? Oh, here, let me turn this on so you can point which ones you don't like. Okay, so that handles the what about null? Okay, then print line. So the equivalent of like console log. All unsafe does is it lets you dereference a raw pointer. The borrow checker, type checker are still active for the most part. The type annotation, all of them, like these 4. That's Rust Analyzer that does that for me. I have no idea if I can turn them off. I could turn Rust Analyzer off, and then go back to RLS. And there's benefits and there's negatives. I like, to be honest, I like the mix of them together. I think RLS does some things better than Rust Analyzer, and I think Rust Analyzer does a lot of things better than RLS. I do think for streaming though, it's really helpful because it shows like what these are for anybody who's watching, and they don't have to necessarily go and look through all of the rest of code to see like, oh, it's just a vector strings. So that being said, I haven't like done a poll to see if it actually is helpful for anybody who's watching. If you press Control-Shift-P and type Rust, there is a toggle. Yeah, there should be a lot of toggle type things that I could do in Rust. Good. As you can see, restart the servers, the #1 commands that I run. I don't think I've ever run debug. Enhanced enter key? Expand macro recursively? Oh, interesting. I've not used any of these. That looks pretty cool. You can bind it to a key. Shame you can only turn it on off. There's 4 different inline hints. Cool. Anyways, so let's see. Basic Rust. We also want probably very early on. We want like a console log. So probably right away. Just in at the beginning, the equivalent of like, so printing to the screen. And we're gonna get 2 things in here. So there's gonna be the print line and the debug are 2 really nice macros. Maybe like down here we can have what are macros, but we're not going to get into like creating them in this tutorial. Enhanced enter key was cool till it wasn't, and you would get comments everywhere you didn't. Ended up wasting time trying to escape a comment. Sometimes it's Rust Analyzer being slow, otherwise it won't work at all. Heap allocation. Yeah, so heap and like the stack for memory is pretty important here. And I'm thinking Like a big part of it is going to be like data structures. Like for example, we want to use the string data structure, which goes onto the heap. Now, am I correct at sort of like at that? That's how it is. Like the string is essentially a data structure of string slices that go on. Yeah, we want to like touch this. String is a heap, not a data structure. Okay, got it. String is on a stack, but it points to data heap. Okay, that's what it is. And slices are just views, right? Curious. Does it put strings in here? Just, okay, string slices go into here. Because if we search for string, so how does it, like, what is its actual verbiage it uses here? The string type. So it's just a type. It has ownerships of the content string as a close relationship with its borrowed counterpart, the primitive stir. But it doesn't really, let's see. String is made up of 3 components, a pointer, some bytes, a length, and a capacity. So if I look at how they implement this, yeah, it's a struct. So a string is a struct. So in essence, it kind of is like, I guess it would probably be like, would be more confusing to say that it is a data structure, even though it kind of is, because we're handing it string, we're handing it essentially stirs, and it's throwing them on a heap and then growing it and shrinking it. Well, it is a data structure just like a vec is. Yeah, exactly. So I think I'm going to put it back into here. Where did I put it? Did I delete it? String. But a really good part of this is we're going to want to talk about heap. And for the primitive types for string, for stir, we want to talk about the stack. Enum isn't a data structure, though it's a data type like a struct or a union is. Oh, okay, that's a good call out. I want to put it. It's not a primitive. It's is it just its own thing? Data structures usually implement some algorithm. A data type is just okay. So just basically normal data types. It's like we have type system primitives, custom types, and then normal types, standard types, just types. This would be like enums. Compound type is usually the verbiage used in many languages. Compound type, I like that. Variant type also, because it consists of multiple other types. Oh, okay. So like, what is a compound type? Consists of multiple. Is it multiple other types, including other compound types? Or primitive types. Eventually it gets down to primitive types. All right, so we just got through print line. Okay, so looping. So we have iterators. I should name this like iteration. And then we're gonna do like a for loop. probably going to do a while loop. Infinite loop would be nice, just like that loop keyword. And then we'll want like actual iterators, which would then give us these. Yeah, eventually we'll be at a set of primitive types. So let's see. Where would I put the borrowing system? I guess like ownership. It's a good. I don't know if I need like anything else. Oh, I guess like ownership, borrowing. You want structs of structs that are structs of enums or something, which of course you can do. And if I think something that like the enums allow us to do that might be the simplest to understand is like holding the anonymous struct, because that's sort of like just creating an object literal in JavaScript. As far as enums versus structs, terms variants, components of an enum. Oh, okay, I always call them arms, but I guess variants is like the more appropriate term versus fields, components of a struct. That's really good. I should note that down here. So we have types, enums with variants. And then something we didn't put in here is, I guess, custom types in here. So enums actually go also into custom types because like we're creating our own type. Do I have structs? Where did I put it? Is it in here? Because like I guess like this one we should just here's what I can do. Creating custom types. I was almost thinking like types provided for us, because like there's some of them, but creating like we also want to create our own custom types. Now, to do that, we can use enums. We can use structs. For enums, you can have named variants, tuple variants, and discriminant variants. Now, I saw the other day in a YouTube video, I saw this pattern, which I haven't seen used. So like, let's do an enum, a thing. And I saw something like, okay, we have a variant A, and it equals to like an I32. I don't think that's valid though, right? Because like I would have to do this as like a tuple type of this. Is this like an old version? Was this something you could do in Rust a long time ago? Oh no, wait, it wasn't I32. Like it was set to 1. Oh, that's something you can do. Okay. That is a thing you can do. Yeah, the equal syntax is a discriminant variant. Okay, so what they were doing was, that's a C-style enum. Okay, yeah, I haven't used very many enums in like C itself. And like this is something I've noticed when I try to use like TypeScript enums or PHP enums. Well, PHP doesn't really have enums, but when you force it in here, this is often something I see where it's like, okay, well, I have A and it's going to be like A. And then like that would be like the truthy thing and B would be like the falsy thing. It lets you cast the enum variant to that number. It's interesting. Can I do this as like a Boolean too? Where I say like true? Just a number. Expected I size found false. So can I only do numbers? That works if you wanted a C-style bit flag enumeration, for example, or jumping a range in it. No, it has to be a size. You can restrict it to some other repr though. Okay, so it has to be something like that. Can I use like that? Okay, no, it has to be. Then the following enums will increment on the one you just set. Yeah. Repr U8 takes up a U8 representation. Oh, so I can set that. Repr U8. So let's see. Oh, so if I set this to be like an F32, then you'll probably yell at me because you're not a F32, and like 29.0 would be happy. Expected eye size? Oh no, okay, so I can't do that. We can't do the math assignment on a Rust enum. They don't exactly act like a C or C++ enum. It still has to be an integer. Okay, so that's nice. That's good to know. So regardless, we have to do this as an integer. I can do like 23 and like a 29, like that. All right, good to know for this. But this form is provided for FFI support mostly, which I haven't done any FFI things in Rust. Maybe someday we'll get into it. I might try, like, one of the future games I do we'll just dive into Godot and try doing that, because that will force us into the entire FFI world, which might be a good way to sort of like learn that. Because I'm having trouble thinking of projects that I want to do on my own that are fun, that would allow me to do FFI type stuff. Either that or like write Rust code and then like export it into like Node.js or PHP for my day job. You can cast that style of enum to that value, but you can't take a value and turn it into that enum. So enum A equals 2, let D equals enum museum, that didn't work because it thinks this is a link. That's weird. Museum, you've been here super helpful for us, so I'm going to do this. VIP museum. Museum, you're now a VIP, so you can now post that code and it won't asterisk you. At least I don't think it will. Yep, so enum A equals 2, let D equals A as U8, but you can't do let A equals 2 as A. Okay, that makes sense. Museum should just pretty much be a global Rust VIP on Twitch. Yeah, like I agree. Museum, I would say is, I'm talking as if Museum is not right here listening, but I would just say like you're a VIP in all of the Rust streams that I've been watching. Rust, they're a little bit more typed. Yeah, I agree. So okay, we have this. Now we also like are running a method off of custom struct. So we have like struct. Inside of here, we're gonna have like methods. Now we also have the colon symbol, which I've talked to some people who are not so in my day job, I've worked with very junior developers that are coming from like code schools. And we dropped them into PHP code, and they came from the Node.js and JavaScript. PHP also has static methods off of classes, and you use the colon syntax. And so just explaining that itself, like that can cause a lot of confusion if you haven't seen it before. And basically saying like, look, oh, this is This is just a, it's not correct to just say like, oh, it's just static method off of basic Rust to do, because this isn't a class. So the colon symbols are going to be important to like I guess symbols are going to be important to discuss. That symbol resolution operator, if you want the fancy name, Rust doesn't have static methods. Yeah. Although it does have like, if you have a struct where it's supposed to be like called off that, it's like kind of like if you're writing object-oriented style code, you can almost see it as a static method, although run in this case is not close to that. So what is that symbol resolution operator? So we want like the symbols. So colon, which is going to be symbol resolution operator. So you could have foo.myAssociated method. Yes, exactly. Or foo colon. Wait, you can have foo dot? I always thought with a capital foo, I thought you'd have to do like a colon for it. Depending upon how foo is defined, yes, okay. I've never defined a struct like foo in a way that I could call a non-associated method without colon. Did I say that right? I don't know. If it's struct foo, then works like colon. Yeah, exactly. And that's how I've always done it. All right. So that's this file. Like that's our simplest file in here. Now, is there any reordering you want to do with this before we get even more complicated? So we have installing Rust. We have our hello world, setting up VS Code. So like maybe we can have like first steps. And then you would be all in here. Then we have the basics of Rust, where we're gonna print things to the screen. We've already done the hello world at that point in time. So now we're going over like explaining what that print line is. Now, these aren't necessarily the order that I'm going to do these in. We should have a simple cargo tutorial. Yeah, that'd be a good idea. Maybe worth considering the format of the Rust book is laid out. Yeah, that's true too. I do actually want to, like, for each of these, have a link to the Rust book with where you can find them too. Simple cargo tutorial. Yeah, that would be a good idea. It's like, this is basics of Rust. These are like coding, like the actual code. Just how to use cargo new, check, build, and run. And I barely use, like 90% of the time, you're just going to use new and run. Cargo clean is huge when you need it. That's true. Cargo clean, like cargo stuff is huge. So like this is going to be outside of the basics of Rust, maybe, because this should be renamed to like the actual like the programming basics or code basics. And we also have like the standard library, and then in here we're gonna have maybe just like the ecosystem, like command line Rust. We could just say like cargo, and then this is going to be like run, new, build. We're going to want like with run and build, both of these together. So this is going to be compiling. And then we're gonna have like the modes. Is it mode? Sort of like debug and release. Let's see, new, let's see, test. Build configuration would be the term. Okay. Configuration. Let's see. We have compiling, new test. We have clean. Wait, isn't there cargo docs too? So like docs. Cargo versus Rust C. Yeah, that's gonna be a big one. Like, what's the difference between Rust C? Like, can't I just call it directly from Rust C? The help documents, yeah, like help. I mean, yeah, we could just do Rust C main.rs, but I wouldn't want anybody brand new to do that. Package management through this. Oh yeah, so like installing packages. We could use probably the nicest one to sort of like use as an example of this would be ripgrep. Even though you can also install this through like apt if you're using Debian-based Linuxes, though. I would stick to Cargo New for, yeah, definitely for newbies. Check is one that people don't use very often. I don't. I'm trying to remember. Like, I don't think I've even used check. See what happens if I use it on here. Yeah, it just checks it. I guess there's nothing wrong. I don't have any warnings, so it doesn't show it. Well, what we're doing, like, so, like, I see myself and like sort of I'm still learning Rust. I like got to the point where I can do actual things with Rust that are useful, and I'm sort of building in that area. Musean, I see you at like a much higher level than I am because you're building the things that allow me to build the things that use Rust. So that's like on one level, at least one level higher than where I am with that right now. Rust Analyzer is running cargo check. Yeah, behind the scenes, like I can go and click on this and get all my problems, which is essentially Rust check behind the scenes. All right. Order. We're going through the order of these. So like printing to the screen, we have variables. Now, the way I'm actually thinking about this, these are not necessarily going to be the right order. So maybe I don't need to worry about this right now. Just categorizing them, and then we'll create a list of lessons afterwards. Yeah, I think that's what I'm going to do. I'm not going to do these as like the orders because it's not going to make sense necessarily for me to do debug right away, but print line will be good. Musean is Rust in your day job. No, although some coworkers and you have been looking at replacing some components in Rust. If they did that, they would be so lucky to have you help out with that. That would be amazing. If the newly formed Rust working group, if they ever like have the money to pay for somebody to like be a Rust evangelist, I would probably vote for you, Museum, to be like the first one to hire. All right, so we have this. Let's go take a look at one of the other files here. We have our main library. So, okay, so with our library system, so our module system, running functions in another file, which means like we have like our live.rs. Bringing in other files. Will Microsoft buy Mozilla and therefore Rust? So I learned this recently. Mozilla is actually two different entities. There is the Mozilla Foundation, and then there's the Mozilla Corporation. And one of them is a for-profit company, and one of them is a non-profit. And so like all of the Rust stuff and all of those like nice things that the Mozilla does that we think about Mozilla comes from the foundation. But like, yeah, Mozilla doesn't own Rust anymore. They pretty quickly got rid of that and sort of made its own thing. Although they do own the trademark for Rust. They have the trademark for some of the Rust. But besides that, they don't really own Rust anymore. They don't even pay for like the Rust servers anymore. That's coming from other people now. But yeah, it was like the Mozilla company that had all those layoffs. And so like it's going to be very interesting to see, like, because one of them could be purchased and the other one could still exist separately. It'll be interesting to see what ends up happening. Yeah, the foundation owns the trademark because Rust doesn't yet have an illegal entity, which they are working on. They put a blog post out. They're very quickly trying to get their own lawyers to sort of like become their own entity. It's going to be good when they eventually do that. And they have a lot of people that sort of like were around when when Mozilla became that public entity after the entire Netscape thing. A long time ago, that they're gonna follow suit and make their own entity. It's gonna be great. So mod, this is gonna be part of the entire running functions in their file, sort of like bringing those in. So it's gonna be like the mod statement. So both mod and use, we're gonna want like publishing, like republishing, like modules / files, components, types, structures, two other files essentially. Make sure you show the difference between using mod for some RS and mod for some directory mod RS. Ooh, that's a really good point. It's like the mod statement, there's the two things. There's the, I guess I could use this as like an example. There's gonna be a mod command, but then there's also just mod command being command.rs in same file, and then mod, let's just say like to do being a folder that has a mod.rs in that folder. Everything is MIT Apache 2.0 and any copyrights are held by the foundation temporarily. Once the entity exists, that trademark will be transferred, but if some corp bought Mozilla Corp, it doesn't grant them ownership of Rust. That would be really nice. I could see Microsoft purchasing some parts of Mozilla, and I could see Microsoft hiring a lot of the Rust developers that are on the core team, and that's mostly because like their discussion about going at like rebuilding some of their core libraries in Rust. As for who pays for Rust servers, Microsoft and Amazon have already provided everything. Yeah, absolutely. Didn't the layoffs mostly go to Swift? Like where, like which parts of the teams they went to? Like there's several people on the core team that were laid off. Microsoft being the biggest spender, and now that they own GitHub and they give risk priority and actions to AI runners. Ooh, that's actually like, it makes sense. It's also like nice for me. Although I don't use actions yet. I haven't set those up at this point in time. Those folks that Mozilla laid off from Rust got headhunted really quick. Yes. Although, like, there's still some people I see in like the various Slack channels and Discords I'm on that have some core members that are still looking. It's like not everyone got headhunted really quickly. There's still some people that are looking as of like, I don't know, a couple days ago. All right, so this is really good to have these. This is sort of like an interesting thing of like the different methods to use. So like the use statement, we have the ability to just like do a normal use. So like, I'll give like these two examples. And that. Let's see. We have public for republishing. We already have functions. For part of functions, we're gonna have like the return types. Static string is gonna be an interesting type to deal with too. So it's like part of type system primitive. We have like string. So that's going to be like the equivalent of like the reference to stir. But then also we're really going to care about static stir also. You might make a distinction between globs in general. A prelude glob. Oh, like, oh yeah, bringing this prelude in. Yeah, that's a good idea. Oh, here, I got the prelude. Let's do something like this. Static stirs is usually a string literal, but not always. I've always used it in the position for a string literal. Like with many things of the rest, I'm not surprised it could be used otherwise. But yeah. Raven Legend, hello, what are we working on today? So I'm coming up with a list of everything that we need in order to build a course that I'm gonna be creating and recording lessons for, episodes for introduction to Rust. I'm in my mind, I'm thinking of JavaScript developers. And that's mostly because my target audience is going to be people who have newly graduated from like a CS degree or a code school and have around a year of experience of like web development of work. And now they want to learn another language that's going to give them like a leg up when trying to get like a second job, a promotion, or just like switch into some alternate work so they're just not building CRUD apps all the time. Or just learn this to like bring into their jobs. Like they just have more than one language of JavaScript essentially. So we're creating a list of like everything you need to know for when WASM takes over. And that's the other thing. I've been watching a lot of WASM stuff, and I'm gonna spend one of my so now I have those Friday exploration days. I'm gonna spend one of the Fridays looking at WASM because I'm really looking forward to sort of learning that. Oh, I don't have that in my. Is that the expanded Twitch or whatever, the like extended thing? Static stirs can be used as a reference to stir because static lifetimes are covariant over specific lifetimes. Right, and static lifetimes being like it's in a binary. It's always there. You can't get rid of it. But variance isn't something that belongs in this guide. Yeah, exactly. You think that's in your Twitch TV stuff? There's that like the extended Twitch TV, I think, like plugin that you can purchase, you can download and use. I don't have that though. All right, so what's next? We have these. We have results. We have that as part of like the error handling that we're returning, that we're dealing with. Command. So we're creating a new command. Okay, so we're going to have as part of error handling. So we have result, unwrapping, and then we want the operator, which is this also just the try operator? I vaguely remember hearing that it's the try operator. No, it's not. The try operator is something different. I can't remember what it's. In your context, it's unwrap. You don't think it has an official name? So at the RESTconf. Oh, it replaced the try macro. That's what it was. Okay. What is that called? Can I search for question mark? Will this help? Question mark, C standard try. Question mark, C standard core try. Okay, so not that one. Not that one. So they just call it question mark operator. There's no link to it. Let's see. How would I search for, would I just search for operators? It wouldn't be a keyword, would it? No. Yeah, I probably would get a better feature, like better answer in a book. And I think that's something I'm going to have to make as part of this, part of like sort of like the documentation lesson, is that you're always going to be going through. You're always going to be going through like, okay, I need to look something up. We're going to look in a book. We're going to look in the which book we're going to look at the book. We're going to look at the standard library documentation, or we're going to look at the recipe guide, like the rest by example. There's just so many different places that we can go to look for it, and they all have different / right information. So I guess like some people call it the clean operator. Some people call it wrong. Some others just say question mark, and that is try, but not a macro. Okay, yeah, there's too much, and it makes it really hard to search for what it is, especially since if I were to like search for like question mark, I get all of these. But I think like I would have to go to one of the other books to actually see what it is. Question mark operator was added to replace try and should be used instead. I wish that there was a link here to like somewhere else with a page just specifically for question mark. Question mark operator for easier area handling. This is in the edition guide Rust 2018. Or is it in here? 3.3, 3.3.1. Yeah, because then this describes like how to use it with this. Like turning this code into this code. So for example, I would take you, go back to here, and we'll put a link in here. So eventually I'm gonna have like links for each of the lessons that I do for like further reading. All right, so we match. Okay, so match, we have iteration. Perhaps like very similar to iteration. We're also gonna have flow. Is it flow and conditionals? It's not really conditional. It's really gonna be about like a programming flow. Flow control. And so we're gonna have like conditionals, like the if statements. We have to have, I guess I'll just say like we have if, and I'm just gonna do if else here. We also have if let and match. Those are the big three flow control that I remember. The question mark operator had the biggest debate up to that point over it. Some very vocal people were very against it and still are. It makes code path less obvious. Yeah, there's I sometimes wonder whether or not I want my my editor to make the question mark a very vibrant different color. So that way I can see it very clearly. Because it's very easy for me to like miss this. Now, that being said, if I were to remove this, it would cause problems immediately. And if I have Rust Analyzer on, I see, oh, your result. Okay, hold on. Question mark, and we're good again. You already color question mark and unwrap an unused magenta edge color. I remember I was watching one of your streams where you were talking about how you'd had two different colors for unwrap sometimes because of that. Did you customize your theme? Is that how you got that, Bear? Another temporary one was it generated slower code than the try macro. Oh, interesting. But that was fixed a while ago, yeah. One thing that I've noticed with just all programming languages, if you program the way that's the most idiomatic and the one that makes the most sense, eventually the compile, maybe not the compile speed, but like the optimizations after, for runtime will catch up to you. All right, so then we have this match. This is also matching off of enums, so that's something that we want to keep an eye on. So we have vex, we have strings, use sizes. Okay, so then remove, list all around, list all. Okay. Then just these other functions sitting here. So we have like private functions versus public functions. If you just write Rust, you usually get good results. Not like C, where making something faster makes it look more cryptic. Yeah, I agree with that. Because question mark had to go through a trait that wasn't always inlined, while try would literally just stamp out an if-else return. So no need to call another method. Oh, nice. But nowadays, it figures that out properly. Returning, okay, so That's this is gonna be part of functions. Now it's not necessarily part of functions because this is all part of like if we have so this is actually a really good point. So in functions, we're gonna want to do something like maybe not even functions. Like at some point, we need when to use semicolons. Because obviously we have like this last line here, no semicolon becomes a implicit return. So implicit return versus elsewhere. But let's see, do I have anything like that here? Yeah, here we have this like match here. So I'm using a match that's not returning anything, and I'm using a match that is returning something. And so I'm using them in like two different ways here. So like this, okay, file, I'm returning file into here. And then this one, I have to like do a specific return call to go out to here. So like it gets interesting. So then I need a semicolon because I'm returning into here, and I don't need a semicolon because I'm not returning. So it's interesting. The implicit code plus trait plus easy to miss plus being posfix or posix was reasonable debates against it. Also adding a new operator will after 1.00 was out. Why can't they add my operator? Postfix. Okay, got it. Let's see. Writing. Send in the standard library, so arguments from the command line. We also want files. So like writing to files, reading from files. And in writing to files, we also need this entire. So when we write to a file, we also care about if we're truncating. So like truncate or append. I think like in generally we care about that the most. Then testing. That's part of the standard library. Want testing. So like how to write the tests. So like tests in the same file. The question mark debate was overshadowed by the impl trait debate and then the await debate. To note, you're fine with the question mark and the .await. Part of the impl trait addition is still wrong in your opinion. Which part do you not like? And what would you do to change it? Or do you know what you would do to change it? Or do you just know that it's not right? Impl trait in argument position. I have seen that. I have seen that in a couple different places, and I haven't used it myself. So I have been confused by that in the past. Yeah, I have seen that. And I was like, what is going on here? What are you doing? That wasn't part of the original spec. It was added last moment. Oh, interesting. So test in the same file. I think that it's probably really good to note that when you compile your code for release mode, it strips out all the tests. So you can have lots and lots of tests, and it won't cause your binary to get any bigger. And I remember asking this a long time ago, and I was told that it will stay in the binary. But can you tell me this, Museum? Do you know? At this point, I might just assume that you know. If I create a test, let's say I move a test right up to here. So I just do like a test. Let's see, what is this? Test list all. If I end up doing this like right here, and so I'm writing my test in line with all these, as opposed to down at the bottom of the file all together. The config test is the important bit. And config test is now a section. Like the rest of the file is now going to be tests. So I have to put these all beneath the config test. That just means it's only included when a configuration value is true. Okay, that makes sense. No, just what that attribute is on. So let's see, we have config test. Oh, because it's in a mod test. So you could do config test. Ooh, okay, so I could do this. We have test. So can I do config test like that? Let's see. Well, that doesn't look that at all. Syntax, close. I maybe have to do both them. I need two attributes. Okay, I need them separately. So I do config test, and then another one for like test, like that. That probably works. All right, and then I can do my tests in line with this. Now, I don't know if I like that, but it is possible to do this, and then these won't be compiled in. Let's see. Septem, hello! You've been following my YouTube channel since you found GGEZ videos, currently watching the series regarding the Rust book. Thanks and keep up the great work. Well, thank you so much for stopping by, Septem. Glad you're able to find this, and I'm glad that all those videos are helping out. One note, I recorded those videos before 2018 edition came out, so some of like the lifetime stuff is not as complicated anymore. It's actually easier to use Rust than it was back in those days. Let's see. A config one first, then the test attribute. So that one, then test. Can you use config attribute and not need both, or will you still need to spec both? Config test tells the compiler to include the item that the attribute is tasked to when the config is true. Okay, so yeah, I could now do these like and move all my tests from like that test section straight up to here, and then this test is like just specifically for list all. I don't know if I actually like this or just putting them all down here in the config section, which also makes a lot of sense to me because I have, for example, I have a helper function that's poorly positioned inside of here somewhere. Here. That like probably should go somewhere else, but it's nice. Like none of these functions will be included in the binary when I compile it for like, you know, release mode. I'm gonna remove you. So we have our test, we have running the tests. Super is gonna be important here, especially if I have something like mod test for that. Now I use this mod test pattern simply because I pulled out of the book and I haven't like seen a reason not to use it. But I guess it's because I want config tests and then that pulls this entire thing out. I wonder if I could just use a block for it instead of like a full mod. I don't know. But all right, so we need, as part of module system, we need super for like pulling from the parent item. Blocks aren't items, so you can't do that. Okay, so we do need it to be a mod because it's not a block. Something else that's really important. I don't really do anything in here, although I'm planning on for each of those other micro lessons. We're gonna make heavy use of them. Is code basics, printing the screen, comments. We have two different comments we're really gonna care about. Just normal comments. And are they block comments? Are they, what are they called? I don't think they're block comments. They're doc comments. That's what it is. Doc comments. If you're coming from Python, those are very familiar. And then also in the testing section, where did I put testing? Testing. So test in the same file, but then also tests in doc comments. Multi-line block. Ooh, you know what? I've never used those. Like, I don't know why. Like, if I just want to like take those off, I just go like that, and that's just like a single one. And I think I can do like a Control Shift. Nope, that's not it. There's some way to like have it automatically turn that into a block comment. I just don't. I don't know. We can show it off. Comments. I just don't really see the need for it. Yeah, if you do multi-line, you just do multiple of them. There's two types of doc comments, by the way. Wait, there are? I haven't like played around with doc comments very much. Inner and outer comments. Let's see if I can find it. So we look at comments. Doc comments. Wait, did you not take me to the right place? It said comments. Oh. What? That's not. Okay. Doc comments. Okay, that's not easy to search for. Okay. Inner and outer comments. Then there's doc tests, yeah. Inner comments go inside of an item, a module. Outer comments go outside of an item, a function. Okay, yeah. So they're not actually different. Like you write them the same way. So for example, for this write all to file, this is an outer comment. So this would be like where we have the description of what it is. They are different. Like they're. Ooh, you have a link for me. Doc comment. Oh my god. Stop. Okay. Highlight. Stop highlighting, please. There. All right. So comment, lecture, line comment, block comment. Okay, so you're a block comment. You're an inner line doc / bang. Oh, interesting. Inner line block doc. Outer line doc. Oh, wow. Okay, I had no idea about all those different type of comments. You can have multi-line dot comments, but they are rare. I can imagine it because personally, I like to see the // in front of it. I don't know, it just is easier for my brain to see what it is. It's also easier to have everything stay in the same line. A dot comment that applies to implicit anonymous module of this crate. Inner line doc. Still an inner line doc with a bang at the beginning. Wow, so many of these comments. Okay, we're gonna put this here in comments, like that. The comments that we really care about, though, are gonna be really just doc comments and normal comments. You'll really need to know about / use the bang one at the top of your module. Okay. And / bang. So this one here would be like write all write contents of out to a file. And then I can say like an example here, and I can actually write this as code, I believe. Oh, and I think that we can also use Markdown in here too. So I can do things like that to like have my actual code. / bang generates the index.html, which consists of the / comments. Yeah, dot comments support markdowns, so tables and all that fancy stuff. Yeah, it's really cool. And then I can put, and I can't remember how off the top of my head. Can I just write code and it turns into a test, or do I have to also give it the test? Okay, and triple checks is code block, which is a compile or run. So now I can do something like, all right, as an example, let I can now call like write, like I guess it would be like let file equals file new, blah blah blah, do all this stuff, and then write all to file, pass it in the appropriate stuff. But it's scoped outside of your crate. Now, when I run cargo test or compile, it will actually run this code, and so your documentation test can actually be really important. You can't use crate, but rather use my crate name, my type, so private stuff is hidden. Okay, that's good to know. It is 12:31. I've been streaming for a little while. I'm gonna do a super quick break. Grab some a quick snack, and then I will be right back. So I'm going to switch over to the quick break screen, and I'll be back in a second. All right, I am back. And I'm going to switch over to standing mode. And I got myself some snacks to eat since I'm streaming through sort of like the lunchtime area. Try not to open it too close to the mic. So what is this? They call it an inner comment or an outer comment? I already forgot. Inner line doc. Top of the file. Okay, so that gives us our comments. We have our tests. Okay, the various asserts. Now, I've always ended up just using assert equals, but there is just a normal assert too. So assert equal. So maybe something to sort of like discuss when setting up VS Code is the REST formatter. So and how basically you can have it's not like JavaScript where, oh hey, let's just run like a linter and one of many billion different ways that we can set up and run our code. That's how we're going to do it. Nope, there is the way to run our code. And Rust format is the way. I know that some other... Does Go do that? I haven't programmed in Go. Does Go have like a standard formatter for it that does like, it's the one format that you use? I know some languages have done that in the past, but not all of them. Okay, so we have this. Okay, so we have enums. Now, specifically, enums can store things. Let's see. We also have, implementation blocks. So basically, adding functions to, I mean, what would I say? Like, this isn't just like adding functions to a data structure, because an enum isn't a data structure. Is it just adding functionality to, I guess, like what can take an impl? No, that's not what I want. Okay, implementation is an item that associates items with an implementing type. Implementations are defined with the keyword impl and contain functions that belong to an instance of the type that is being implemented or to the type statically. Inherent implementations, that's what it is. So this is an inherent implementation where I'm adding functions or functionality to this specific enum instance or instance. Where did I put my enums? Oh, impl blocks. So this is inherit. Inherit, and what was the other one? Trait. All right. The rest of it is like pretty much the same. It's just code. So looking through here, we have, I see the format macro, and I also see this. So perhaps off of the standard library, we have some like useful macros. So format is one of them. I know that like print line and debug are nice too. But then where would I put like, what's the official term for the underscore here in this case? Like I usually use like catch all, but I don't think that's like the actual term for it. It's like flow control with match, and then we also have like underscore as a catch-all. And that's kind of it for like this super bare basics. So what am I missing in here? I'll probably figure it out as we go through it. Like obviously there's a lot more primitive types that we're going to care about than just like string and usize. All right, so we have, maybe these aren't like the lessons list. This is going to be like the topics. And then we're going to want the actual lessons. So I'm thinking this could be like a table that we create that's going to have the lesson that we care about, the URL. So here's what I would see it. It would be lesson title. In a table, I have to do like start with the pipe 2, I think. Lesson title, then what is it? The next thing is going to be like the video URL. Maybe just like the video. I'm going to want the repo. So the challenge repo. And associated like further reading. Basically, that's probably what I'm gonna want. So if we take a look at this, an example would be, we're gonna start with like introduction, like the super introduction to the course. So introduction to the course. The video hasn't been created yet, but maybe what I can do is do something like this. Maybe I actually want this to be the lesson title and the video sort of go hand in hand. So you'd be like that. You don't exist yet, so you're not going to go anywhere. The challenge repo is also going to be inside of here. And maybe there is none. So like NA. And then further reading, maybe there's NA for this one too. Okay, so like introduction to the course, okay, that's fine, that's kind of boring. Let's find one that we would have something to go in across like all of them. Hello World, I want them to do their own, so therefore I'm not going to be creating a repo for that. A channel badge has been located? Wait, what does that mean? And I also see that you're now blue. Oh yeah, I created a Rust channel badge and I put the Rust logo on there. I forgot about that. Nobody had found it yet. I tend to like add things in and then just like not advertise them out just to see if anybody finds it. Yep, you're the first. I sort of made it brown like that because the black logo just didn't, you can't see it. And then I didn't want to make it white because not everyone's going to have a black chat background. Some people will have the white background. So I figured brown was the best. Also, it looks rusted, so that works. Okay, so let's do something like let's do like vectors. So maybe the title might be something like storing data in vectors. This would be something like a link to a YouTube. So like youtube.com/ something like that. The challenge repo would obviously be something like github.com/Brooks. Did I put it? I don't remember if I put a dash in my name. Brooks build / it would be something like intro to rest slash. I'm thinking that I'll just have a single intro to rest repo, and then I'm going to want to do a this is maybe not the maybe we'll do assessment here. So intro to rest, and then slash the you're gonna steal the idea for your channel? Oh, absolutely. You'll make a different badge though? Oh yeah, no problem whatsoever. I pulled this off of the Rust homepage, and then down below in the stream description, I put an attribute to it because I was just looking through their requirements for it. That's all they require is attribute. So intro to Rust slash like maybe vectors. And then the final thing is further reading. We'd go to either the Rust reference. So how do I do like multiple things here? It's a good question. If I do like a vector, well, that's not helpful. I guess you don't have anything like with vectors directly in it. That's interesting. I would need to go to. Okay, I probably want to go to like the Rust standard library. Go to like a vector here. Really? Am I spelling vector? No, that's not right. Oh, it's a vec. Ah, because it's vec, not vector. I always forget that because like I say vector out loud when it's a vec. So it'd be something like standard library vector like that. Now if I want to make this, I don't know what this is going to look like in the table format. So then one other thing would be maybe coming here. This is the addition guide. That's not helpful. If I look for vec. Can I find actual vector array types? No. Is there a vec type? There's sequence types. That's not really what I want. Let's go find the book. I have the Markdown preview extension, right? Yeah, it's in the standard. So here I can test this with Markdown open preview. Okay, so that starts. Oh, this is not a table at all. Well, that's cool. I always screw up tables when I first do them. Oh, I need the, okay, the dash. That's what I missed. So it's, this is right. But then I need in here, like that. And then the end too. So if I do that, we go back to, there we go. Okay, so this gives me, oh, you became underscore. What? I want you to be something like you. Because I don't think I can do like this. This would be like maybe the book. How about dash? Yeah, because that just becomes dash there. I don't think I want to do this as like multi-lines, because that's going to look terrible. Yeah, that doesn't actually come over into further reading. How would I want to like make those look properly? I think then I don't want to put the further reading stuff inside of here. It wouldn't be in this table. I would want to, oh my God, what did you do, VS Code? Looks terrible. Let's see, introduction to the course, string vector. So we're gonna not have further reading. We're gonna have challenge assessment. You're really gonna be, you're gonna get further reading there, and you're also gonna get the assessment. So the associated, like the reference, the code. So if I do that, string data and vectors, that takes you to, so we have the, we have the lesson. Let's do that too. There, code plus assessment. Okay, so introduction to the course, string data and vectors, and then this takes you to the appropriate place. Obviously that doesn't exist right now, so I can't actually click on it. Now, what I want this to look like is going to be interesting. This is probably going to be like in the main file, like the main README for the intro to Rust. We'll have all this. I guess like this one will have, the final one will have like the final project. And it will be like after a lesson, we'll have final project and it links to this repo. Here, let's go down into playgrounds. Let's do cargo new. How do I want to do this? Do I want to do new? I can't write tests instead of main, right? I don't think it's possible for me to like have a config section for a test. Actually, let's try this. Let's create a function like create a vector, and I want them to return a new vec with I32s in it. So if I do something like that, then does this work? I want to assert assert equal that a vec of like 1, 2, and 3 is equal to create a vector like that. Cannot find function create a vector. Okay, so we have to use super that. It gets me there. Okay, so create a vector. Does this actually run? I think I'm going to want to use, hey, it works. Okay, not yet implemented. So then here, if I return you to be a vec of like 1, 2, 3, you pass. So while this is easy for this, I don't necessarily think this is a super good idea for like these specific tests. I think what I'm actually going to want to do is maybe create something called like assessments. Nope, not that. Oh, right, because you don't exist. I can still, it doesn't really matter. I can still open it up. I'm going to change it from a binary package. So like instead of a main.rs, let's just rename this to live.rs. And then we can have our config like that here. And then I could like write all the testing code specifically here. But more importantly than that, I could create modules for each of the lessons, as it were. I like that. Okay, so let's say in here, oh, you're lagging? My CPU is like 1.3, so I'm not using very many of those, but I have dropped 44 frames in total across the entirety of the stream, so not very recently. So I don't know if it's me who's causing a lag, or if like Twitch is causing a lag. It's on you, not me. So I often watch streams on my my iPad, which I have an ancient iPad, and it just, because it's an ancient iPad, runs out of memory and the CPU is terrible. I have to constantly pause and resume, just like what you said, in order to like get it to catch up. But I'm way behind on every stream that I watch, just because of that. All right, so what if I do this? If I do like mod vectors. Now it says your latency is negative 0.13. Oh my gosh. Well, in that case, Bear, tell me what I'm doing. That's clearly better than what I've got. Like, you're faster than me, and I'm the one doing it. Okay, so vectors, cannot find vectors RS. Mr. Bahan, have I had a chance to play with Rune, a dynamic language on Rust? I saw some announcements about Rune on the Reddit, but I haven't seen any, I haven't looked at it at all. But what I can do is make a note down to do a Exploration Friday on Rune. So I'm not gonna promise that I'm actually going to get to it, or when I'm gonna get to it, but I will add it to my list. Explore Rune. Language for Rust. Or language in Rust. I guess one of the things is I'm having so much fun programming in Rust. I'm not sure I want to program in another language just because it's made on Rust. All right, so we have vectors here. I'm going to create a vectors.rs. I'm going to put, I don't have any of these tests anymore. One question, your beginner wants to know when I should return impl trait and when to return box dyn trait. What's the difference? So the dyn trait, so are you familiar, if I say the words dynamic dispatch, are you familiar with what that means? Yes, okay. So a box dyn trait is essentially going to do dynamic dispatch. You can have you can store different types as long as they implement trait. You could store them into whatever you're in there. So let's say I have this. Go ahead. Let me say I have this struct. I'll just do like a game object, because I've done this pattern quite a few times. If I have a game object, let's say, and I want a whole bunch of things to be able to stored inside of it. For example, I want a physics system. I'll just call it physics. But I want each different types of object to have different types of physics. So I want the players to have their own physics, and instead of me having player physics or whatever, I can just say, well, I want you to be a box that has a dyn trait of maybe the physics trait. And so then that way, I'm saying that I want this to be dynamically dispatched. So that way I can store anything that implements physics is boxed up and placed right here and stored in here. The box type isn't that important. It's the impl trait versus the dyn trait. You can have arc dyn trait and even Lifetime A dyne trait. I've never used those. Wait, have I? You know, I think I did an arc box dyne trait once because I thought he had to do that. So that's probably nice that I could just do an arc dyne trait. Box is common because it's single owner and lets you mutates them. Okay, that makes sense. But dyne trait requires some heap allocation and hence Bach art, right? I believe you're right. But anyways, like this is the main use that I have for it. So now when I return, I don't often return a dyne trait. Instead, I sort of implement the trait and then box it up when I add it onto the game object. So I don't think I've ever run into a situation where I need to return a impl trait or a dyne trait. Dyne trait does not require heap allocation. Let tdyne standard format debug equals reference to 42 is totally on the stack. Oh, nice. A dyne trait is a type that isn't known statically at compile time. Right, so for example, in this case, I'm gonna have a struct, I'm gonna have a trait physics, and I might have, for this, it's probably gonna have like a function update. It's gonna take in like mute self and like something else, like maybe like just a location, which I'll just say right now is, let's just say it's a tuple of like F32, F32. And we're not gonna return anything. So if that's the trait physics, and then I'm gonna have a struct physics system that maybe will have something like a location that's like an F32 for its XY. And maybe I might have some other stuff on there. When I go to create this game object, I almost always do like an impl physics system, have a hub function new, take in like the location, maybe like an X and a Y. And then we're going to do location is X and Y there like that. You're happy for that. And then I want to impl physics for physics system. And then just put this method update there. Maybe I'll do something like, oh, you need to be mutable. It's not like that, is it? Patterns aren't allowed and functions without bodies. Okay, hold on. Can I do that? Yeah, okay, that's what I want to do. Mutable reference to all these. And then I might do something like location.0 plus equals to like 1.0. Something like that to make it move across the screen. And so now when I create the game object, I can box up physics. So like in my main function, I would do something along the lines of let's to make it more realistic. We do game object, a function new. All right, so let like the player physics will be the physics system new, and I'll just say like 50.0, 50.0. That's where the player is starting. and then I create a new game object and store that in it as a box. So like game object new. I guess I'm already in here. Hold on. Then we're gonna do, oh right, self. So we're gonna store a game object. Physics is gonna be a box new layer physics is gonna be what's stored in there, and I need to say that you're returning a game object. So basically that's sort of like the pattern what I would do with like the box and dine and like impulse with traits. Is between me and Museum, is that answering your question, Mr. Bond? And I think we did use, we have done like a dine trait plus two, or no, what did we do? We did it in a trait once for one of the things in order to be able to like clone or copy. I want to know about functions returning impl. So that would be something like in physics here. Let's not do trait. Let's do impl physics system. We just like do some other thing. So like pub function do something, and we're going to return impl, I don't know, physics, something like that. Those basically generate an anonymous struct, and the compiler impls that trait for it by inlining the trait impl of the type you're returning. Returning a dine trait returns the pointer to a vtable. So can I return a dine impl physics? You should almost never have a function return a dine trait unless you're doing an up downcast later. Okay, that makes sense. Also explains why I've never seen it. E.g., you're returning a box dine any. And that makes sense to like return a box dine any. So like I could have like a box it, like new box. And that could also return, like take an X, 32 and a Y, F32. I don't know, can I like do an impl physics like this? I don't think I can, right? Because this one needs it to be, you can only do the impl physics if it, auto derives. It's like physics system. Like that. Huh, I guess that works. Oh, because you have this on here. If I didn't do that, then it wouldn't impl. So I can do this one here because I do impl physics for physics systems. Therefore, I'm returning this. Now, that being said, I don't know if there's a difference between this and that. Oh, slower compiling. Definitely not slower at runtime, but sure, the compiler has to generate more code, but it's also up to 30% slower at runtime, hours per second. Talking about 10% total build time for hundreds of impl traits. Okay, so it's like not super slower. Oh, you're returning. Yeah, so like I could say that this is returning an impl, something that implements physics. That's what I'm saying. I'm returning something that implements physics, and there it is, the anonymous struct physics system that implements physics. Now that being said, I could also just box it up. Which the way like that I tend to use all of these, like the dynamic dispatch, this is probably what I would end up doing, just because I need to box it anyways. Like that. So does that, okay, now have we answered your question? I can also box it up later when I need it. And you can accept a dying trait where an impl trait is used in the argument position. I have seen that also. Although usually I accept a boxed because I usually want to mutate it. You can pass around as reference to mute impl foo. Oh, really? Awesome. Glad I was able to help. Although I think Musean did a lot of the heavy lifting there. So thank you, Musean, for helping. Help. Just function f foo is a immutable reference of f that take a box dying trait or a t some impl trait. Oh, nice. Oh, right, because it's a generic at that point. But yeah, generics via monomorphization does have an impact on build times. I think like anytime you pull generics in, it starts having impact on build times because it has to now generate all the code for all the different possibilities. Or am I think that's what's happening behind the scenes. But it's how Rust can be as fast as C++. Yeah, at runtime. Like it sacrifices build time for runtime. Okay. If I wanted to like do a section on vectors, here's where we would have maybe like some documentation for introduction to vectors. Then we're gonna have the functions that we're gonna call. So maybe we'll just do like creating a vector by hand, like function create vector, and it's going to return a vector of like an I32. And then inside of here, we're going to say create a vector that holds I32s, place like 10, place the numbers 1 through 5 in it. For example, 1, 2, 3, 4, 5. Something like that. Then we have here that we're just going to return, so like let place your code here, so like implement your code here. I'll put like the to-do in so it doesn't yell at me. Okay, so then we create a test here. Name of the test is going to be test create vector. So that we'll just run the vector. So like let result and then you're going to be 1, 2, 3, 4, 5. Assert equal. That result is the same as create vector, like that. Generics being slow to compile is relative. How slow is slow? Is it slower than build scripts? Usually not. Slower than proc macros? Almost never. Slower than a linker and a fat ito release build? It contributes to that slowness. LTO. Okay. My font doesn't differentiate lowercase. Link time optimization. Oh, interesting. Okay. Yeah, I've not really delved much into like the compiler behind the scenes of like what's happening there. Okay. So like if I do this, then we've mod vectors. Do I need to do anything else in order to have this work? So like if I do cargo test at this point. Okay, yeah, panicked at not yet implemented. Perfect. So for example, the lesson that I would do is like I do a video on vectors and creating the vectors and like all the different little things about it. Probably maybe including the macro for it, and then the automated tests that come in. So like I would probably try to have 5 examples to work with here. So like, okay, we have create vector, for example. So like create vector and like push into vectors, maybe various things like that. And then I'd have the tests all in here. And then your job after, like as a learner, your job would be watch the video, read anything you need to, and then make all the tests pass by implementing the code here. So in this case, we want to just create a simple vector that holds these 5 things. We could do something like let mute numbers equals, the test module doesn't have to be public. Okay, that's good to know. Just mod test, vec new. In fact, it shouldn't ever be public. Yeah, that's a good idea. All right, so then we create a new vector, and then we just push numbers into it. Now, like in this specific one, I'd probably want to do like a for reasoning. It should just be local to the current module because that's the unit under test. Yeah, okay, yeah, that's a really good point. So then inside of here, we do like for count in 1 ... Is ... in standard yet? Can I do that yet? And then numbers.push count. Oh, it's ... equals. And then return numbers. So if I do that, then it should pass and everything's good. Triple dot got deprecated. Okay, that. I remember like seeing the triple dots and I was like, oh, okay, this is cool. And then like I never noticed when the equal sign came in. But all right, so like this would be, for example, the way that the student would complete this micro assessment, and then I want them to do it like 3 to 5 times. But like it doesn't have to be exactly the same, obviously. I just want it to be something to do with vectors. So maybe another one would be like create an empty vector with size like 8. And then of course I'd maybe have like the rest of the description there. So create empty vector, a vec of like I32. And then here I'd want, we'll start with to do. Do something very simple, so like test, create empty vector. And so then in this case, I want there to be nothing in it. So let's see, how would I do that? Let result equals test create empty vector, result dot, I think I can get the the length, right? Will the length actually tell me what the size is? Oh, will you not work because I've not, wait, not test, create empty vector. So let's see, obviously there's length. So I should be able to do something like, okay, I want the result to equal 8, for example. And you're going to be upset such that two expressions are equal to each other. Yeah, I want you to be dot length. You're going to fail to begin with because I'm not, it's unimplemented. So we're going to turn a new vector, let's say. Okay, yeah, so its length is not 8 properly. So I think what I can do is I can return a vec I32. Is it semicolon 8? Or is it, I can't remember here where I can like set the size. New vector not allocate until vector optimum dynamically size. I know you can set the size on something though ahead of time, because I've done that before. Maybe I need, okay, so let my vector equals vec. Right, yeah, and so I know I can do an array like that. I could swear that I've created a vector with size though before. So like I can do my vector dot set length. But that's not right. Like that's not a good idea. I just where is that? I know at some point in time you can pre-allocate them. Oh, with capacity, that's what it was. You can set it with capacity. Yeah, so I can say like, okay, I want it to be like of a length of this amount. Now, I don't know if that's helpful in actually doing a lesson of like how to do that. It's probably a lot more helpful to like create an empty vector as like one function here and have another function to like push something into an empty vector. So like then you can have like the push and you can have like pop and do those off of it. And then these would all be functions that then I can test individually. So like create empty vector, I want you to like create that and we're going to return an empty vector. All it does is pre-allocate at least 3 slots. Yeah, which is probably not helpful in like that. If I want realistic stuff, create an empty vector, all that I want here is I want an empty vector like that to be equal to create empty vector like that. And so, oh, can I not do that? Oh, type annotations needed. That result. And I want you to be a vec I32. But you can tell the start of some specific number will round to a power of 2 after 7 and page aligned. Oh, interesting. The vec doesn't allocate, then allocates 137 and grows by 1.5 times each time. Okay, that makes sense. And then you, we're gonna say you are result, that. And then I want like maybe another test. And in this case, we'll like test pushing to vector. And this will be that results equals a vec of like 1. Assert equal. That result is the same as push to vector and pass it in a result. Yeah, okay, beginners shouldn't need to worry about that. The push, extend, and append are much more important. So then here I can have like this push to vector function. And you're gonna, and I might want them to actually create the function too for it. So maybe for like one of them, I can have them as an example, but part of the videos will be like, here's how to do these. I need you to like write this full function. So I might even start it without this. So let's run this first. So push to vector, we're gonna have like a mutable reference. No, wrong way. This is gonna be our vector. It's gonna be a mutable reference to a vec of I32. We're not gonna return anything. And I'm gonna take the vector and push in 1. And this, you need to be a mutable reference. So you need to be mutable. Can't compare vector, the trait. Partial compare is not implemented for vectors of I32. Oh wait, it isn't? Ooh. I guess I could, I don't think I can like implement that trait myself. Oh, that's too bad. That I can't like set this as a vector and compare them to each other. Not for a unit. One of your types is a unit. So we have a vec like that. Oh, and oh, you got it. You got, yep. Hold on. I want to push to vector, hand it. I didn't think about it. I don't return anything. Hand it that, and you, I want to be a new vec of 1. Like that. That's what I want. So if I run this, it fails. Where does it fail on? Pushing to vector. Left doesn't need right. So I don't want to push you in. I just want an empty vector there, and then I have a vector like that. Okay, so everything works there. And then the idea is that I would write the documentation for this and say, okay, pushing into a vec, vectors include standard, helpful standard methods. Like push that allow us to add to the vector. Create a function named push to vector. Create a function named push to vector that takes in a mutable reference to a vector and adds the I32 value 1 to it. By the way, like in Markdown, doc comments 2 lines without a blank line between them will be combined. Oh no! Okay, so hold on. I need to do that. Interesting. Because they're, oh, okay, so then this one is actually fine to do that. And I could just, to make it nice and simple, just do that there. You know, now that I think about this, these my tests should probably just be doc tests. So I can just do like example, like not example, but like how it's used, like how this will be used. That's going to be like let let numbers equals vec new then I'm going to call push to vector, pass it in a mutable reference to numbers, semicolon, and then assert equal that numbers is the same as a vec new. I guess not that. I want like a vec one. Something like that. So if I do this, I don't need this test anymore. I'm now going to be doing this as doc tests. And so if I run cargo test, okay, so running push to vector, line 27. Failed. Failures. Expected one of these. Found this. Oh, it doesn't like my title here. Line 28 isn't a comment. I can do that. That's how I want to do it. Okay, so failed. Cannot find function push to vector in its scope. Okay, so even though this test is right here, it doesn't know how to find it. Do I have to use it? Now you need to be public and reference it from the external path. Okay, so I need to pub this. Doc tests are all public facing. Okay. Okay, so make that public. and then I have to use it then? So think of it as a second crate using that. So I have to use, do I have to use like super? Push to vector, like that. Yeah, you can use hash use my crate name. It has to be the name of your crate, which would be like, I guess in this case, it's assessments. It's like use assessments vectors. Push to vector, like that. Oh, and the pound will hide it, so I can do that, but it's still going, okay, that's what pound does in here. Okay. All right, so if I do this, still this, so mod vectors. Let's see, where's my module vectors is private. Vectors is private, so up here I need to pub this. There you go. And so this this needs to be public. Okay, so thank you for that. Now if I do a cargo, what is it the command to build the docs? Is it cargo doc? Build this package and dependencies documentation. Yeah. So cargo doc, and then cargo. There's a way. Oh, cargo doc open. Oh, that opened in the wrong file, wrong browser. There we go. Okay, so here's vectors. So we come into here, push to vector. Okay, so then public function, push to vector, vector this. So it describes what this is. It gives the little example of the little like snippet, how this will be used, and then that's where this is. And then you come into the code to make it work. But if you want to like see the docs for it, to actually see in a very nice laid out way of like, this is the example of how I'm going to be using this function. And the test for it is written right in here. So you don't have to go down to find somewhere else to see how I'm planning on using this. It's just right here. XO220C, today has been a trip. It had been a while since you opened Game Maker, and it updated 2.3, so you decided to launch a project and see if it would just work. And did it? Lines 23, 24 should be separated. Yeah, pushing it into a vac. Yeah, right there. If you go back to the vectors module doc view, you'll see it shows both lines. Yeah, okay, so obviously that's not gonna update this. I need to rerun. Oh, that builds it too. Okay, nice. Be over there like that. Hit refresh, and here we go. Okay, pushing into a vector. The first line is always the short description. Oh, interesting. Okay. And then here I have introduction to vectors. Turns out they changed the way global script works, and now rather than the scripts being the functions the scripts require function sets to be used. Oh, that's gonna be a big breaking change. I go up to the module and you'll see the short one. Like go up one. Oh, right, we did. hold on, let me go up here. Introduction to vectors is this one right here. So this is where I can put something like assessments for the vectors lesson. And can I put like links into here? Would that work? Link to videos like that. Oh, there it goes. Instead, I can put like a link to the videos for that. So essentially, I can use the Rust documentation as part of the course. That's going to be so nice. Now you're having to go through all of your scripts and add functions to them because it didn't auto reformat them. Oh, that's fun in a terrible way. This is really nice. I like this a lot. And then the order of this is probably the same order that I put them in here. So I can, in the order that I expect you to go through the course, I can set all of these up here, and I can even put in like this own like a course. Oh, it's alphabetical. Oh no. It's like course, like modules. Course modules as part of the introduction to Rust. Mod 00 intro. Okay, yeah, I'll probably have to do that then. So like if I do, now I can also do AAAs for this is like introduction to vectors, what they are and how to use them. So if I do that, oh, interesting. They that doesn't show above them, sort of like what I was expecting to. That shows as part of like to the left of it. It's not. It's inline as the short description. Yeah, I see that now. I guess there's no way for me to get something above that, is there? So then I would not put this here. You got to put that up here. Oh, nope, that's wrong. Introduction to vectors, what they are, and how to use them. And so that's what I have to do there. And then I will do modules. And then what you're suggesting is I create another module here. So let's say we have like functions. RS. Let's say I want to do functions. Oh, my own editor is changing that. Okay, so if I switch you to format on save, don't. Save you. Rebuild. Yeah, it still puts it up top. So you're right, Museum. So we're gonna have to put we're gonna have to create some kind of like naming scheme, like what you're suggesting with like the mod 001, in order to like keep the order that we want to keep them in. Let's see. I missed a bunch from you, XO. So you have to put functions around function insert script name here around all of your scripts. Now you're wondering if I compiled function and script sets rather than interval scripts to do things, and even coding pick it up, which would mean less scripts and less memory used, but still keep all the functionality. So generally, like the more modular that you can keep all of your code base, the better it's going to be for you, because if you need to change something, it's going to be easier to change it. So that's probably what you want. Put a blank line between them to stop it. Ooh, okay, so if I do that, then back to here. Oh, no, need to reformat. RestDoc doesn't care about my blank lines. Oh, okay, hold on. If I do that, but then also do this, these are functions. It probably doesn't care about this either. Yeah, it just moves that comment straight into there. Okay, so we will have to do some kind of naming scheme to keep them in the correct order to make sense. All right. That works. And so then this will be what it sort of looks like. So I can use the documentation as part of the course. Okay, awesome. All right. I like where we're going with this. So next steps. We have a list of all of these. What I probably want to do is create a repo where all of the lessons are going to live. And in that repo is going to be a modular system exactly like this. So I'm probably just going to use a library format for the rest. We'll put code, like the code comments in here, and then the various lessons of what we need. Like basically, I can, instead of the README will be very simple. It just says, go to the Rust documentation area to sort of like see all of this. And basically maybe instructions for how to compile the Rust documentation on your own system and then open it up. You can put the README in the lib.rs and just copy it out to your markdown for the repo. Oh wait, I could put the README in the lib.rs? Oh wait, because I could put where is that? In here. Oh, this is wrong. Yes, good. In here in lib.rs, we just put all the doc. We just put the README in here. Yeah, exactly. And then yeah, we can copy it over there. I guess I'll need to remember to do that every time I do that. Common mark flavor if you need to see what exactly is supported. Everything that I do that's normal should probably work out for that pretty well. I don't think I'm going to do anything crazy with it. Just like simple links, the code. There's a cargo plugin called Cargo README. Does that create a README for me automatically? Cargo new. What is it? Is it cargo dash README? Keep on forgetting I have to press return. Cargo-README, a cargo subcommand to generate readme.md content from doc comments. Nice, okay, so cargo-README. I think I added this in where I can now do cargo add cargo README. Okay, so then can I do, let's see, how do I use it? Oh, okay. It adds it to the project. It's not going to be part of the project that I can do. I was hoping that I can like have a line in the code that would automatically export this. That would have been pretty amazing. Like every time I run like a cargo build or cargo docs build, it would like do that for me. That would be nice. All right, so I need a cargo remove this. What is it? Cargo uninstall? Cargo del? Or I could just go to Toml and remove you. Cargo RM. Let's try it. There you go. Okay, perfect. That did it. So okay, I want to do cargo install cargo readme. You don't know of an automatic Rust markdown? There is a markdown to Rust for running unit tests in your README. Ooh, interesting. But of course, unit tests like this one would solve it the opposite direction. So if I now do, what is this? Cargo README. So if I just do cargo README, it should go out to a standard out. Yeah, okay. So cargo README to readme.md. That creates this file that then has that there. So I just need to remember to run cargo readme for that. All right, perfect. So then the lessons for this, let's see, the actual lessons. Where did we end up on? Over here. So if we actually have like the full lessons that we do, we're going to do introduction to Rust, why Rust, installing Rust on Windows, installing Rust on Linux, installing Rust on Mac. Is that? These are good. Include the MD into your live.rs. Yeah, that's sort of what I was figuring, and that would cause the unit test to run. And so then if you use that tool, your unit tests are all going to run, and it's going to be fine. All right, so then we have our hello world. So hello world in Rust. That's that. So then, okay, we want to like set up VS Code. Setting up VS Code for Rust development. So like essentially these are done. Actually, can I just comment you out? Oh yeah. It's like you're done. It's like all of this stuff would be taken care of as part of that. And then that would be the first steps here. Then we'd probably get into it's like Hello World in Rust. That kind of, so part of Hello World is going to run through cargo new. And cargo run. And that's going to be like the setup. So that'll be like the section for this. Maybe like introduction. Okay, so then we're actually just gonna get into like the coding. So like, oh, you can't get it to work? Oh no. I actually was thinking that would work out. Was going to be using include notes, not include string, include bytes. Oh, okay. I wonder, like, do simple tests work? Includes a REST source into the current file. Oh, interesting. And does include normally work in tests? In test documentation? All right, so in coding Rust, then we're probably going to go into like the basic, like super basic types. I think I may have to stop the stream though before I go too far, because I notice I'm getting really hungry and it's like 2 o'clock and I only had 2 small snacks. So I think I'm going to keep on working on this on my own. And then I'm hoping that next time, so on Sunday next week, we can begin recording these lessons and then putting them up on YouTube, and it'll be great. Whether or not like we record the lessons or we actually build out the repos first, that's gonna be a question like I'm not completely sure of yet. But that's the plan. So I'm gonna go ahead and start winding this down. See, it's close all view up. There's not really anything that I need to like push up code-wise. That to-do application was already up on GitHub, and I believe I have a link to that in case you wanted to see it at Bang Repo. Except the bot crashed. Okay, so that needs to be fixed. I have my chatbot is a very old version of the Twitch chat museum that's running on a DigitalOcean server, and I need to update it to like newer things so it doesn't stop working as often. I think something got stuck about it, and I don't know what, and it needs to like be restarted, and there's the thread that's like stuck somewhere. It's most likely me that's done something wrong and like using it wrong, but I'm not getting any logs or like any error messages out of it, which is a little bit unfortunate. But I need to rebuild it now that I have a better way to handle all of like the Twitch stats, so I can use that instead. All right, everybody. I am going to switch over to our ending screen. Thank you all so much for stopping by. I do these tutorial Sundays. So next week, I sort of mentioned, we're going to be coming back and continuing on with this project and creating all of the tutorials. And then also on weekdays, Monday through Thursday, I have just sort of like project days. They're usually from around 7 a.m. Mountain Time to 8:15, 8:30 in the morning Mountain Time for me to work on whatever I want to work on. Almost always Rust. And Fridays, I just added a new show. That's going to be Exploration Fridays. We took a look at the Bevy game engine this last Friday, and we'll figure out what else to look at this next one. So again, there. Thank you everybody for stopping by and watching. I am going to take off and have lunch. Hope that you all have a great rest of your day, and I will see you all next time. Bye.